Hello students, Unit 5 Vector Calculus, and the topic to be discussed today is Stoke's theorem. So let's as always have the outline, introduction of Stoke's theorem, the working procedure, problems and final conclusion. So let's start up with the introduction. A theorem proposing that the surface integral of the curl of a function over any surface bounded by a closed path is equal to the line integral of a particular vector function round that path. Stoke's theorem is a statement about the integration of differential forms on manifolds, which both simplifies and generalizes several theorems from vector calculus. So, this is the statement of Stoke's theorem. So, we have already discussed what is Gauss divergence theorem earlier in the previous videos. Now, Stoke's theorem is just have a look at this theorem. It need not to be a hemisphere. It can be a parallelepiped which is open on one side or a single surface or anything we can do. We can find out or we can verify Stoke's theorem. So it states that line integral of a vector field. Remember, line integral, as discussed in my introduction video, line integral is nothing but a single integral. A line integral of a vector field around any closed surface C is equal to the surface integral of the normal component of curl of vector over an unclosed surface S, and S is the outward or normal. So this is the statement of Stokes theorem. So always remember, Stokes theorem is a theorem which connects double integral to a single integral, which is the line integral. So surface integral is equal to a line integral in Stokes theorem, whereas in Gauss divergence, volume integral is equal to the surface integral. So remember this, we move on. So this is a statement of Stokes theorem. So we start with the problem. Justify Stokes theorem for f vector is equal to x square plus y square I vector minus 2xy j vector taken around the rectangle bounded by the lines x is equal to plus or minus a, y is equal to 0 and y is equal to b. So you can draw a rectangle. It's very simple. So by Stokes theorem, this is a statement of Stokes theorem. Integral over C f vector or dr vector is equal to double integral over S del cross f vector dot n cap ds. So what is f vector? So first you will start the right hand side and complete the left hand side, or vice versa you can start up. So I have taken the right hand side first, evaluated, and then moving on to the line integral. So for a rectangle, how many lines will be there? 4 lines are there. So we'll be finding 4 lines. And how many surfaces are there? For a rectangle, there is only one surface. So we'll be doing surface, only one surface here and 4 lines. Okay. So a vector, you know what to do, how to find a curl of the vector, right? Curl or cross product. So I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and f vector coefficient of I vector is x square plus y square, and coefficient of j vector is minus 2xy. So I have taken minus 2xy, and there is no k vector, so it is going to be 0. Right? Expanding, I am getting minus 4y k vector. Remember, minus 4y k vector. So now, sorry. Now we have the RHS to be completed. So RHS equations, double integral over S del cross F vector dot n cap ds. So you already calculated del cross F. Del cross F is minus 4y k vector, and the n cap is nothing but dot k vector. How this n cap is k vector here? Because we know there is a rectangle which is in xy plane. A surface, any surface in xy plane, the vector drawn, outward drawn normal vector will be definitely in the direction of z vector. So sorry, z axis. So it's going to be k vector. So taking the dot product, it's going to be minus y 4y. Integrating, you know what is the limits for x? X is varying between minus a to plus a, and the limits of y is 0 to b. It's already given in the problems. So in the problem question, so evaluate it and you get the answer as minus 4ab square. So next step will be moving on to the left hand side. As I told you, there are 4 lines. So you are having, I have just randomly named it as A, B, C, D. So 4 lines I have taken accordingly. So F vector, you know what is dr vector, right? F vector dot dr vector, that is a statement of your line integral. So taking the dot product between F vector and dr vector, remember dr vector is dx I vector plus dy j vector plus dz k vector. Taking the dot product between these two, you will be getting x square plus y square dx, and here while taking the dot product, minus 2xy dy. So taking the dot product, and this is your integral over c f vector dot dr vector. So as you know, a single integral can be evaluated only by a single differential inside it. You cannot have dy as well as dx. So what do I do? For all the 4 lines, I will be discussing what line it is and which variable is remaining a constant. This is very important. Along that particular line, which line is remaining a constant. So that particular line I will make it as 0, or that variable will be made as 0 or whatever it is accordingly. So first let me take line AB. Line AB. So first I've named the lines, 4 lines as A, B, C, D. So since you can even name it as 0 O A B C, no issues. So integral over AB minus a to plus a x square dx. So while integrating, so what has happened to this dy? So dy has become 0. How? Because in that particular line, first line, you have y is equal to 0. So y is equal to 0, which is equal to integral over minus a to plus a is equal to 2a cube by 3. And next comes along BC. So along BC, you know, along BC, x is equal to a, and since x is a constant, differentiating you get it as 0. So now substituting, x will go. So dz will also get vanished. So only dy will be remaining, integrating. And then along CD again y is some constant, taking the value b. So when I integrate it, dy is going to be 0. Sorry. Now coming to along dA will be having x is equal to minus a and dz equal to 0. So automatically you could see that symmetrically 2 of the integrals dx is becoming 0 and the other 2 integrals dy is becoming 0. Okay. So obviously you are getting 4 integrals with respect to one differential, and easily you can differentiate it and equate, finding all the 4 integrals, adding up all the 4 values, you are getting the answer as minus 4ab square. Hence Stokes theorem is verified. So we move on to the second problem. Consider a unit cube. Okay. Now this is the second category of the problem where you are not given a single surface. In the previous problem there was a single surface given. Here a unit cube is given. Okay. Unit cube is given, is open on the top, it is saying. So automatically in a cube you will be having 6 surfaces, right? This type of problem we have already seen in Gauss divergence. So, but what is the difference between this problem of Stokes and the other problem in Gauss divergence theorem? In Stokes theorem, one surface will be open. It can be any surface, the top surface or the bottom surface, or any surface out of the 6 surfaces. Whereas in Gauss divergence, all the 6 surfaces will be intact, which is a closed diagram, closed figure, right? So unit cube, which is open on the top. So now you will be having left over only 5 surfaces, right? And on the top surface of that particular cube, you can take the line integral, which will be considering of 4 lines. So this is your F vector. This F vector is having I vector, J vector and K vector. No issues in that. Defend, which means prove that the surface of the cube equals its line integral of the open surface, which means the Stokes theorem. Surface integral equating to line integral happens only in Stokes. Right, I'm sorry I mentioned it wrong. So by Stokes theorem, this is the F vector. So you know what is the statement of Stokes theorem. So we need curl of that vector. So from the given vector, you take the curl, right? And you, as I told you, there are having 6 surfaces you are having: S1, S2, S3, S4, S5, and S6. Sorry, S5, 5 surfaces. So you'll be finding accordingly. You can verify this with your Gauss divergence theorem earlier in my videos. So as I told you, S1 will be X surface, which is positive side. So I'll be having I vector, and the differential will be dy dz. Whenever I'm considering X surface, the order of differential will be dy dz. And whenever I'm having Y surface, whenever I'm considering Y surface, the order of differential will be dx dz. And whenever I am having z surface or z plane, I will be taking the order of difference integration will be dx dy, right? So always try to remember positive side I vector, negative side minus I. Positive side of y j vector, negative side of y minus j vector. Positive side of z is k vector. And what has happened to the negative side of 0? That side is not existing because that has been removed, which has already been mentioned in the problem. So finally, integrating, adding up all the 5 values, I am getting the answer as minus 1. So problems for practice. Now you can take up this problem. It is same as your first problem. Considering the region in the XOY plane bounded by the lines x is equal to 0, x is equal to a, and y equal to 0 and y equal to b. It is again a rectangle. Evaluate the following: the vector using Stokes theorem. Thank you.